see the working of a DC motor. We know that since the discovery of electricity or the invention of electric generators, people have been using electricity to do lots of work. Electricity is a kind of energy, and that energy can be used to do lot of work. So DC motor is an application of electricity where electrical energy is converted into a mechanical energy. So DC motor is a instrument, or it is a machine which converts electrical energy into a mechanical energy. So the principle behind the working of a DC motor is the magnetic effect of an electric current. It is observed that if a current carrying conductor is placed perpendicular to the magnetic field, force acts on the conductor perpendicular to direction of the magnetic field and perpendicular to the direction of current carrying conductor. So the principle of working of a DC motor is Fleming's left hand rule, which says that the force acts on a current carrying conductor kept perpendicular to the magnetic field, and this force is perpendicular to both magnetic field and the current carrying direction of the current carrying conductor. So DC motor, there are two types of motor, DC motor and AC motor. DC motor is a motor which works on a batteries or direct currents, and AC motors are the motor which run on the electric alternating current. For example, the fans that we use at home are alternating current motors, whereas the toy car motors are if the toy car is using a battery, then the toy car motor is a DC motor. So let us see the working of a DC motor or a direct current motor. So basically, whenever we study the direct current motor, we need to see certain things. These 1, 2, 3, 4 things are very important while understanding the direct current motor. For example, principle of direct current motor is a Fleming's left hand rule, or or we can say the force acts on a current carrying conductor perpendicular to the perpendicular of direction of a magnetic field and perpendicular to the direction of current. So force acts on a conductor if the current carrying conductor is placed perpendicular to the direction of a magnetic field. Okay, so here we will see, so that is the principle of DC motor. Next thing that we need to understand is the construction. What is the construction of a DC motor? Now let us see the diagram. This diagram is of a single DC motor. These are the two different diagrams at two different angles, but it is the same thing. So the construction of a DC motor. Let us see the construction of a DC motor. DC motor consists of a two permanent horseshoe magnet, north and south. These are very strong magnets which are kept in the direction of north to south. North is facing towards the south of the magnet, and they are horseshoe magnet. They are very strong and the permanent magnet. Then the next thing is the battery switch, and we can say a resistance added so that to give some load. And then there are two brushes, B1 and B2. B1 and B2 are two brushes which are in contact with the split rings R1 and R2. R1 and R2 are the two split rings, and this R1 and R2 can move with the axle. Let us see what is axle and the armature. This is an axle, or it is a rod on which a coil ABCD is wound. So coil ABCD and the axle is also called as armature, and this coil has two ends. One end of the coil is connected to the split ring R1 and the other end is connected to split ring R2. Remember students, the one end of the ring R1, one end of the coil is connected to R1 and not to B1. B1 and B2 are fixed. R1 and R2 can move. They can move, so it's connected like this, so that the ring can move like this. So brush B1 is in contact with ring R1 and brush B2 is in contact with ring R2. So my dear students, try to understand the construction. Once again, north permanent, strong permanent magnets, two split rings R1 and R2, which are also called as commutator, which commutes the current or which changes the direction of the current two times in a single rotation, and therefore the split ring arrangement is also called as a commutator arrangement. Brush B1 and B2 provide electrical contact with the ring R1 and R2, and this is the coil ABCD. In the figure there is only one turn of the coil is shown, but there are thousands of turns in a DC motor or in the armature. So let us see the working of the DC motor. So according to the DC motor is a motor in which magnetic field and the electric current are given as input and we get force as an output. So according to the Fleming's left hand rule, this finger stands for the direction of a direction of force, and this finger stands for the direction of a magnetic field, and this finger stands for the direction of the current. So this finger, this is north and this is south, this is the direction of force, and this is plus and this is minus. So this finger represents the direction of current, this finger represents the direction of a magnetic field, and this finger represents the direction of the force. So let us apply the Fleming's left hand rule to the DC motor. So when switch is on, the current starts to flow, the current enters into brush B1. Brush B1 are the carbon brushes, they are made up of conductors, and this brush B1 sends the current into R1. Then R1 is connected to the one end of the coil A. One end of the coil is soldered to R1 and the another end of the coil is soldered to ring R2. So the current enters from B1 to R1 and the current flows to D, comes to R2, come to B2 and comes back to the negative terminal. So applying Fleming's left hand rule, it is said that the direction of a magnetic field is north to south, direction of current is that, so the force acts on the arm AB in the downward direction. So if you apply the Fleming's left hand rule to the arm ABCD, arm AB, direction of the arm, the current of direction of arm AB is that, direction of magnetic field is this is north south plus minus, so the force acts in the downward direction. So AB moves down, and if you apply the same Fleming's left hand rule to the arm CD, direction of the magnetic field north to south, current is flowing from C to D, so the force acts on the arm CD in the upward direction. So the force acts on arm CD in the upward direction, force acts on the arm AB in the downward direction, and therefore there is a torque. A torque acts on the arm, on the coil ABCD, and the coil ABCD makes a half rotation. As soon as it makes a half rotation, we see that R2 comes this side, R2 comes this side after half rotation, and R1 goes that side. Okay, after half rotation, that is after 180 degrees. This is after 180 degrees, this is 0 degrees. So after 180 degree of rotation, you can see arm AB has gone down that side and arm CD has gone this side. Now as soon as arm CD comes this side, R2 comes in contact with B1 and R1 comes in contact with B2. Now let us see, B1 is supplying a positive, is connected to the positive terminal, so the current is entering through B1. So as the current enters through B1, it goes to R2, D, C, B, A, R1, B2 and comes back to the negative terminal. Okay, so therefore force acts on the arm CD. Apply the Fleming's left hand rule. This is the north pole, south pole, current is flowing from D to C. Force acts on the CD in the downward direction. And applying Fleming's left hand rule to the arm AB, this is the direction of a magnetic field north to south, current is flowing from B to C, force acts on arm AB upward. So force acts on arm AB upward, and here we get one more complete half revolution. So here we see that in first half, as soon as we switch it on, the coil moves makes a 180-degree rotation. After 180 degrees rotation, again the arm AB moves up and CD moves down. In this way we get a complete rotatory, one complete revolution. And after this, again the our armature comes to this position, again R1 comes in contact with B1, and again AB goes down and CD moves up. And in this way the armature ABCD continuously starts to rotate in a or starts to rotate or starts to get a rotatory motion. So it is a complete rotatory motion received by the armature. Okay, so applications of the DC motor. DC motor is widely used in the all the electronic things where there is a direct current use. For example, DVDs, CDs, or toy cars, or in industries, or in trams, locomotives. DC motor is used. Very strong DC motors are used in trams and locomotives. Then one more thing that we need to remember is how can the strength of the DC motor be increased. Strength of the DC motor can be increased by increasing the strength of the magnet. First factor, increasing the strength of the magnet. Second, by increasing the number of turns of the magnet, turns of the coil. So first factor, how can we increase the strength of the DC motor? First, increase the strength of the magnetic field. Second, increase the number of turns of the coil. Third, increase the current flowing through the coil. Fourth, laminate the axle. And the final one, increase the area of cross section of the coil. So if you will be doing these 5 things, then the strength of the DC motor will increase. So whenever DC motor is to be written for 5 marks, remember we need to draw the diagrams, both the diagrams. We have to write the principle, that is Fleming's left hand rule. Then the construction, we have to write information about strong magnets, split ring, brush B1 and B2, and the coil. So that comes in the construction. Then we have to explain about the working, and then we have to write the applications. So dear students, I hope you have understood the working of a DC motor. Please draw the diagram carefully. Thank you.
Students, you can see the animation of this DC motor. You can see there are 2 split rings and there are 2 brushes B1 and B2. The 2 split rings come in the contact of brush B1 and B2 as the motor rotates, and you can see there is a change in the direction of current in the coil twice in one complete revolution. The red part of the magnet is the north pole, which is showing by the direction of the magnet is shown by the blue lines. Direction of the current is shown by the red lines, and the direction of the force is shown by the black line. You can see the direction of force over there. You can also refer to this website volterfindt.de for